customer edge to provider edge dynamic routing. Let's jump in. Here are the opt-out questions for this video. So take a moment, read through these questions, and if you're already really comfortable with these concepts and how they work, hey, I'll see you in the next video. Otherwise, let's begin. If somebody walked up to us and said, hey, can you tell me how to share large numbers of routes between two routers and to do it dynamically so as routes show up in one, they're advertised automatically to the other? And the answer to that question, of course, is yes, we could use something called a routing protocol. And we have routing protocols like IGPs, interior gateway protocols like OSPF and RIP and EIGRP. And we also have exterior gateway routing protocols. In fact, there's only one exterior routing protocol that we really use, and that is Border Gateway Protocol. So regarding sharing routes between the customer edge and the provider edge, we can do so using any of these routing protocols that we want to. And it doesn't have to be the same one on both sides. For example, between Acme and R1, we might use OSPF, and over on R5 to Acme Site 2, we could use RIP. So you don't have to use the exact same routing protocol for the same customer at two different edges of the network. So here's what we get to do. We're going to go ahead and use OSPF right here between Acme Site 1 and R1. And we'll just put all the routes in area 0. And for routing between CBT at Site 1 and R1, we'll go ahead and use EIGRP. And in our example, we'll go ahead and use EIGRP Autonomous System number 102 between CBT at Site 1 and R1. Over here at the top right of our topology, we'll use RIP version 2 between R5 and Acme at Site 2. And for the routing between R5 and CBT at Site 2, let's go ahead and use BGP. In fact, let's use the Autonomous System number of 65,537. So our Autonomous System number is 65,536, and if the router at CBT at Site 2 is running BGP running 65,537, and we become neighbors, that will make it an external BGP session between R5 and CBT Site 2. Now, if we do use Border Gateway Protocol between R5 and CBT2, there is one additional change that we're going to make to our network, and that is we are going to modify the BGP session that's between R1 and R5. And we'll simply modify R5 so that any routes that we advertise will set router 5's loopback as the next hop. And we'll use the next hop self command for that. Because the default behavior with BGP is this. Let's say we have an IP address right here on CBT Site 2, which is 192.168.202.2. That's going to be the IP address that we are going to configure on that interface at CBT Site 2. And if this router, CBT Site 2, advertises the route, the default behavior regarding the next hop is to carry that IP address as the next hop into our autonomous system. So by using this next hop self option, when R5 does receive any external BGP routes, before it advertises those routes over to R1, it'll simply swap out and replace the next hop with its own IP address, which in our case is 5.5.5.5. Now I've got this topology along with the routing protocols that we're going to be using. I put a picture of that inside of the NuggetLab file. So if you want to open that up separately or have it as a reference while we're doing the configuration, feel free to take a look at that. When we configure these CE devices, it's really pretty much standard configuration for OSPF, EIGRP, RIP, and Border Gateway Protocol. What is different, however, is when we configure those same routing protocols on R1 and R5, we don't do it just as we traditionally would, because we have to create those routing processes and associate them specifically with the VRFs. So we need to run OSPF in the VRF for Acme, and we need to run EIGRP in the VRF for CBT. And the same with RIP and Border Gateway Protocol. And so what I thought would be the most efficient use of our time is I will walk you through step by step on how to do that for each of these 4 routing protocols that we're going to use in our example. So we'll start at the PEs. We'll do R1 first. We'll create all of the routing configuration for the VRFs, and then we'll go to R5, and then with our provider edge equipment done, we'll go to the edges, and we'll do Acme 1, CBT 1, Acme 2, and CBT 2. So here's the trick. On R1, when we create router OSPF and whatever the process ID we want to use, we're going to use the VRF keyword and associate that specific routing process, in this case OSPF, with that VRF. So from R1's perspective, OSPF process ID 101 belongs completely to the VRF called 101:Acme, and any interfaces that are inside of that VRF, which also have exactly this IP address based on this wildcard mask, are going to be in area 0. And that happens to be the exact IP address that we configured on this PE interface in the previous nugget. So from a router perspective, that's really all we need to form an OSPF adjacency between the VRF sitting at R1 and Acme 1 once Acme is configured. Next, let's configure the routing protocols to support CBT at Site 1, which is EIGRP. Now, this one is a lot of fun. It's a little bit different. What we're going to do is we are going to go ahead and specify router EIGRP1, and then we are going to specify the address family for the VRF. So very much like what we did inside of BGP, when we go into this address family configuration mode for IP version 4, that's just basic normal IP, focused on the VRF called 102:CBT, we're going to use the autonomous system number of 102. So even though we created this EIGRP autonomous system number 1, for VRF 102:CBT, we are going to be using 102. That means when we go to configure CBT at Site 1, the customer edge router, we're just going to tell that customer edge that the autonomous system number is 102. Now, I have seen on different versions of iOS that this may be slightly different. So if you're running on slightly different code for whatever reason, this is a good real-world tip as well, is go ahead and use the question mark to see what the next options are when you're putting in the syntax. So now, in this special address family configuration mode for VRF 102:CBT, we can now do network statements and other EIGRP-related commands that will only apply to this VRF 102:CBT. So let's add a network statement. So that will cover the interface on R1 and make it participate as part of EIGRP as it communicates over or will communicate over with CBT at Site 1. So this, my friend, is our routing protocols, one per VRF that we're using to support our customer edge devices. So now that the two VRFs on R1 are set up as far as routing for the customer edges, we also need to do the similar treatment on R5, except on R5 we're going to use RIP to support our customer edge with Acme, and we're going to use BGP to support our CBT customer edge. So the commands will be slightly different. So here on R5, we're going to go into configuration mode, go into router RIP. I say we want to use version 2, and then we're going to enter address family for IPv4 VRF 101:ACME. And anything we do inside of that address family configuration is going to apply just for that VRF. So again, anytime we see the command IPv4, just think normal IPv4 routing, no special tags, no labels, just normal IPv4 type of stuff. And then of course with the VRF and the name of the VRF, we're simply identifying where we want this RIP routing protocol and the details we're about to enter to apply. So we're going to enter the network statement of 192.168.202.0, and that will cover the FA2/0 interface on R5. And with RIP, there is no option to use a wildcard mask, even if we wanted to. And then we're going to do no auto summary because we don't want auto summarization on, which RIP over the years has been very prone to do. So we'll turn off auto summary. So now on R5, we've got the routing protocol in place on the PE, ready to support Acme at Site 2. So next, let's go into BGP configuration mode. Now on R5, we're in Autonomous System 65536, and to go into the section for the VRF, we're going to use the address family command once again. So inside of BGP, address family IPv4, again, that's just referring to plain old normal IPv4 routes. We want to enter configuration mode for the VRF called 102:CBT. And then anything we put here will apply just for that VRF. So all we really need to do here is do a neighbor statement to point to the IP address that CBT at Site 2 is eventually going to have once we configure it. So we'll do a neighbor 192.168.202.2, which is the IP address that CBT at Site 2 will have. And the remote autonomous system that CBT at Site 2 is running is going to be 65,537, which is different than ours, which makes us external BGP neighbors. If we want to prevent that next hop from propagating inside of our system, we want to make sure that R5 changes the next hop to itself for any routes that it advertises into R1. So to do that, I'm going to go into address family for VPN v4 and specify, hey, my good buddy neighbor 1111, if I send him any updates, I'm going to change out that next hop to be myself. And that's all the neighbor next hop self command is doing for us right here. And to seal the deal, I'm going to go ahead and clear my IP BGP sessions. Now in a production environment, this could be an RPE, a resume producing event. But in a test environment with no production on the line, we can reset a BGP neighborship and it's not that big of a deal. So of course what we'd want to do now is we'd want to save our configurations on R1. So I'm going to go ahead and do a WR to save that, and also on R5 with a WR or a copy run start, however you'd like to do that. The other thing I'd recommend you do is take GNS3 periodically, and once you save your configurations on your routers, also go inside of GNS3 and save your project as well to make sure you can save all that work that you've done. The other thing I have for you in the Nugget Lab files is all of this configuration for routing on the PEs and the configuration on the CEs that we're about to do right now. I've put for you in a script file that's part of the Nugget Lab files. So if you want to refer to that and look over those commands, as you implement this and practice with it yourself, feel free to take advantage of those resources that you have as a member. So here's our game plan. We're going to go to each of the customer edge routers. We're going to start with Acme at Site 1, and we're going to bring up the interface, the one that's physically connected down to the PE. We're also going to create a loopback address that we can also advertise to the PE. That way we can verify by looking at the routing tables on the PE routers, R1 and R5. We can actually verify that the routing protocol is actually working if we can see that loopback. So here at Acme 1, we'll go into configuration mode. We'll go into interface config for FA2/0, bring it up with the no shutdown command. We'll put the IP address with the 101 subnet with .2 with the /30 mask. And for loopback 0, we're going to use 111 in the third octet and make that a 32-bit mask. So that's basic IP addressing on interfaces and bringing interfaces up. Now our next logical step is to set up the routing protocol on the Acme Site 1 router. And we're running OSPF, so all we really need to do is create an OSPF process. This is not in any type of VRF. The customer edge really has no idea or knowledge of what the service provider is doing. They're just running plain old OSPF. So we go into router config, and this statement right here basically says every single interface based on this wildcard mask, every interface that I currently have or I will have in the future is going to be participating in OSPF. And those interfaces will be part of Area 0. And the good news is, based on this message right here, we do have an OSPF adjacency between Acme 1 and the provider edge, which also means that we should be seeing an OSPF route of 172.16.111.2 inside of R1 in the VRF for Acme. So I'm game. Let's go over to R1 for a moment, and on R1, let's go ahead and simply ask, please show us the IP routing table for the VRF called 101 Acme. And sure enough, we've got some routes. We've got a directly connected network. We've got a local network based on iOS 15 showing us that. And most importantly, we have this OSPF learned route. Fantastic. That's the 172.16.111.2 with a 32-bit mask. There's the administrative distance for OSPF. There's the cost to get to that. There's our next hop address, and there's our egress interface that we would use if we ever needed to forward a packet to that IP address. So that's one customer edge that's set up. That's Acme 1. Let's go to CBT1, bottom left-hand corner of our topology, and let's configure him as well. We'll simply bring up the interface FA2/1. We'll give it the IP address with the 101 in the third octet and .2/30 mask. A loopback address, loopback 0, with the 222 in that third octet with a 32-bit mask. And again, that's just the interface to physically connect to the service provider, and one loopback that we can play with the routing protocol. Now, because the R1 router is running EIGRP, and from the customer's perspective is Autonomous System 102, all we need to do is enable EIGRP, Autonomous System number 102, add a network statement to include some interfaces. We can do a no auto summary just to make sure we're not doing auto summary by default. Based on the version of iOS you're using, some versions do auto summary, some don't. I always like to err on the side of caution and say no, please don't auto summarize. And this network says any interfaces that are directly connected are going to be participating in EIGRP. And there's our neighbor statement, which is fantastic. So that implies that our EIGRP routing is working between CBT at Site 1 on the customer edge and R1 from the VRF associated with CBT. So we could certainly test that as well. So this network right here, 172.16.222.2, if the routing's working, that route should show up in the CBT VRF in R1. So we go over to R1 just for a moment and take a look at the output of a show IP route for VRF 102:CBT. So from R1's perspective, this looks great. We have an EIGRP learned route of 172.16.222.2/32. There's the administrative distance for EIGRP. There's the metric. There's our next hop, which is actually CBT at Site 1. That's his IP address. And our egress interface that we'd use if we ever wanted to forward a packet to that destination would be R1's FA2/1, which is allocated to the VRF of CBT. So that looks great as well. So we've got two more customer edges to do. Let's go up to Acme 2 in the top right-hand corner of our topology, and we'll go ahead and set up a couple of interfaces there. So FA2/0 is the interface that connects down to R5. We'll bring that up. We'll give it the IP address of on the 202 network of .2 with a /30-bit mask, and loopback 0 with the third octet being 111, which is very similar to what we've done on the other two CEs. Just an IP address on the interface to connect to the PE and a loopback address as well. Now, going back to our game plan with Acme 2 and R5 was to use RIP to exchange routes back and forth, version 2 specifically. So on Acme 2, we just configure normal RIP with version 2, a network statement to include the interfaces you want to participate. In this example, network 0000, which simply says all directly connected networks and interfaces are participating inside of RIP. And so once this converges, we should have a nice routing protocol going back and forth between Acme 2 and R5. So if we wanted to see if this loopback address of 192.168.111.2, let's see if it actually made it into the VRF for Acme. We can go back to R5 and simply ask R5, hey, please show us the IP routing table for VRF 101:Acme. And sure enough, there we have a RIP learned route right there. There's the administrative distance for RIP. There's our hop count. All right, so we have one more customer edge to do, and that's CBT at site 2 in the bottom right-hand corner of our topology. So we'll go into configuration mode. We'll bring up interface FA2/1, give it the IP address on the 202 subnet of .2 with the /30, and the loopback address is going to be 222 on that third octet and .2 with a /32-bit mask. Now for the routing protocol, we decided we're going to use BGP between CBT2 and R5, and we're going to use router BGP 65537, and we're simply going to tell CBT at site 2, hey, your neighbor is the IP address of R5, and his autonomous system number is 65536. So because CBT2 is using this autonomous system number, and its neighbor, who's R5, is using this one, that would make them external BGP neighbors. And that neighborship has come up. That's fantastic. So with the other customer edges, we included those loopbacks on Acme 1, CBT 1, and Acme 2. We included those loopback interfaces in their IGPs. In Border Gateway Protocol, we need some mechanism of bringing the loopback on CBT at site 2 also into BGP. So we can take a look at that and verify that route exists on R5 in the VRF for CBT. So we could use a network statement, or we could simply redistribute connected. So any interfaces, including loopback 0, would be injected into BGP and could then be shared over to R5. So now in R5, if we want to make a road trip over there and take a look at the routing table for just CBT's VRF, we could do a show IP route VRF 102:CBT, and sure enough, there it is. Now BGP is not the fastest routing protocol to converge, so if you add a route and then check in the next 10-15 seconds, it may take a minute to actually show up. So whenever you're working with BGP, you'd want to give it a few moments to go ahead and converge. So there's our BGP learned route, the loopback that's sitting on CBT at site 2. There's the administrative distance for an external BGP learned route. There's our next hop, which is the IP address at CBT2 on its Ethernet interface. And what that does, it validates. When we look at the VRF routing tables on the PEs, it validates that our routing protocols between the PEs and the respective customer edges are all working correctly. Now, what should you and I do after we do all of this configuration? Well, the answer is we should probably practice it several times. The more you practice it, the better you'll get with it. And then secondly, we probably ought to save all of our work. So I'm going to go to each of these devices and save our configs. There's Acme, and there's CBT, there's R1, and R2 we didn't touch, R3 we didn't touch, R4 we didn't touch, R5 we did quite a bit of work on. We'll make sure that's saved as well. Acme at site 2 is saved, and CBT at site 2. So now that those are all saved, I would strongly recommend you bring in your GNS3 application if you're using GNS3 and save that project here as well. Because we're going to be building on top of this as we take our next logical step in the course together. And you might ask, Keith, what is that next logical step? And the next logical step is to make sure that we can get the routes that we learned, for example, in OSPF, in the VRF for Acme. We need to make sure we can export those into BGP. And the routes that we learned from EIGRP, we need to make sure we are exporting those into multi-protocol BGP. The same with RIP. I have had a great time in this video, and your action item, my friend, is to make sure that you practice in implementing the routing protocols that you're going to use between the CE and the Provider Edge. The very first time you do it, if you haven't done it before, it might be a little bit awkward because there's some new commands. And that's why I've included the scripts for exactly what you've seen us do together in this video. That script is in the Nugget Lab files for you to refer to. Secondly, I'd like you to take a look at those opt-out questions one more time. Now that we've gone through this content together and you've practiced it in your own lab environment, take a look at those opt-out questions and see how well you can now do with those questions. I have had a great time and I really appreciate you joining me for this video. I hope this has been informative for you, and I'd like to thank you for viewing.